Okay, sorry. Okay. Can you see the? Oh, give me a minute. This mic. Okay. Okay, sorry. So, can you see the screen now? Okay. Can you see the screen?
Yes, sir.
Okay. Thank you. So, here idea is to realize in general there is no connection between get a. So, what this exercise you have to realize that in general there is no direct connection between the limit limit at a point and the function value. No, here we got here both of them are defined but they are different. Here I have the limit but no function value. Here you have the function value but limit is not defined. No, so in the first example both are defined and they are the same. Okay, so if the limit is defined and same, here you can see there are jump, here there is a jump in the function. No, there here there is a fall in the function. Okay, this one again a jump, sudden jump in the function value.
Excuse me, sir.
Oh, okay.
You're sharing the wrong thing.
Oh, thank you. Let's see. Dex of one, dex of two. Okay. Can you see the correct screen now?
Yes, sir.
Okay, thank you. Okay, so here again if I explain there, here there are no direct connection between line and the function value. Function value එකයි a point a function value එකයි limit එකයි අතර සම්බන්ධයක් නැහැ සාමාන්‍යයෙන් කෙලින්ම නේ මේ මොකද මෙතන ඒ දෙකම තියෙනවා මේ function value එක නැහැ. Okay, here both of them are defined but they are different. Okay, here function value is undefined, limit is there. Make a function value එක නැහැ limit එක තියෙනවා. Okay, here limit no limit but function value is defined. Function value එක define වෙලා. Only first example we had everything defined and equal. Okay, if you look at the where these two are different, here there's a hole. මෙතන function එකේ හිඩසක් තියෙනවා නේ. Here jump, here is a jump. Okay, here all everything is same, no jump or no holes. Okay, so this connection of the function value and the limit are equal when there are no jumps in the function. Jumps or holes, we can draw the function by one line without lifting the pencil. No, මේ function value එකයි limit එකයි සමාන වෙන්නේ ඒ function එකේ jumps, sudden jumps එකපාරට උඩ වෙනස් වෙන value එහෙම නැති වෙලාවට නේ we can මේක එක pencil පාරකින් අඳින්න පුළුවන්. Okay, So intuitively, those situation we say function is continuous. Okay. 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 Okay, this is exercise. So this is the similar exercise. I'll leave it as a homework. Here, for example, I start from here. I am getting close to this 4, no? This side 1. Okay, negative 2, no? So another way to intuitively so remember that idea about the continuity, we'll come back for that. Also, we can tell by function values by looking at a graph. No, here when I come to this 0 along the positive values, I'm getting close to 2. No, see this side is so. When I come to 0 along negative values, still I am getting to 2, so I can say the limit of function is 2. මෙතන මේ ටේබල් එකක් බලලා කියන්නේ මේ ඍණ පැත්තෙනුයි ධන පැත්තෙනුයි එනකොට මේ values බලලා දෙකට ලං වෙනවයි කියලා කියන්න පුළුවන් limit එක. හරි? හැබැයි ඒ ටේබල් එක හොඳ නැහැ, මේක undefined limit එකක්. මේ sin 1 over x, this sin 1 over x is again undefined limit. What happens, graphs jumps fast up and down, jump very quickly, graph keep jumping up and down. Okay. From when I approach from this side also, it's crazily oscillate. So I cannot tell what is the limit at 1 over x, okay, because 1 over x also undefined. So there's a hole there in the function, and limit I cannot tell because it start to jump up and down. Okay. So table is not a very good way to tell the limit. We can only make a guess, because if someone make a table only using these high points, no, very close high points, they will say think limit is going to 1, actually when there is no limit. Someone uses these only these point to make the limit guess, they will think it's going to -1, because without looking at the graph you don't know if we make the table we might miss some key points, no, because table only lists finite number of values. මෙතන මේ ටේබල් එකක් පාවිච්චි කළාත් අපිට ලිමිට් එකට ගෙස් එකක් කරන්න පුළුවන්. දැන් මේක බැලුවම මට පේනවා දෙකට යනවා වගේ ලිමිට් එකනේ දෙපැත්තෙන්ම. හැබැයි මෙතන මේ පැත්තෙනුයි දෙකට යනවා වගේ. ඕකේ, උනාට ටේබල් එකක් එච්චර හොඳ නැහැ. මොකද උදාහරණයක් හැටියට මේ graph එක ගත්තොත් මේක උඩ පහත යනවා හරි වේගෙන්. බිඳුවට ලං වෙන්න, බිඳුව අනිත් එක undefined. හරි? එතකොට මට කියන්න බෑ මේකේ ලිමිට් එක මොකක්ද කියලා නේ. එතකොට මේ ටේබල් එකක් හැදුවොත් එක්කෙනෙක් graph එක දිහා බලන්න නැතුව වැරදිලා මේ points විතරක් ගන්න පුළුවන්. එයා දන්නේ නැති නිසා මොකද්ද වෙන්නේ කියලා function එකට. එහෙම ගත්තොත් එයා හිතනවා මේක එකට යනවා කියලා. තව එක්කෙනෙක් මේ උඩ යට කෙළවර අරන් ටේබල් එක හැදුවොත් එයා හිතනවා රින් එකට යනවා කියලා. ඒකෝට ටේබල් එකෙන් ගෙස් කරන්න විතරයි. අපිට graph එක තියෙනවා නම් හරියට කියන්න පුළුවන්. Okay, so if we have the graph we can tell the limit correctly if a correct graph. Okay, but the problem is we cannot draw the graph always because it can get very complicated or maybe even not drawable, or it might become complicated. graph එකක් හැබැයි හැමතිස්සෙම අපිට ගන්න බෑ. okay, සමහර වෙලාවට ඒක complicated වෙන්න පුළුවන්. okay, so there are some ways to do that. This is the continuity idea I told. okay, so when function is continuous, this one we can use it as a theorem or a definition. okay, so fc is defined, limit x going to c, fx is defined, limit x goes to c, fx equals fc. okay, I'll make it a theorem because we will be using two more Okay, here is saying function value defined. Here two-sided limit defined and they are equal, like this case. No, when we come here, we get that all conditions true නේ. මෙතනදී අපිට කැඩෙන condition එකේ number එක කියන්න පුළුවන්. Okay, so this is if we have the graph. Okay, if we have the graph, we can calculate the limit. We can use this theorem. Okay, now there are two definitions epsilon L. Now we cannot draw the graph. Okay, so we should be able to talk about limit using other means, because always we cannot draw a graph and table don't work. Table එකත් හරියන්නේ අපිට හැමතිස්සෙම graph එක හොයන්නත් බැරි නිසා තියෙනවා මේ epsilon delta definition කියලා. Okay, for any given epsilon, I will write here, there exists delta greater than 0, okay. So from this we can calculate the not calculate, we from this we can find some limits, okay, for basic functions. And also there is a epsilon delta definition for continuity. Okay, we'll not go over those because we discuss in detail concept around the limit definition for sequence. These ones are also similar, you will learn them later. Okay, so using these things and stuff, you can come up with way to calculate limit for the functions. Okay, so I think in high school you did also these things. So high school එකේදීත් කරා මේක. හරි, මේ epsilon delta definition එක කරලා නැහැ. epsilon delta definition එක ඔයගොල්ලෝ පස්සේ ඉගෙන ගනි මේකට. හරි, so you learn, ඔයගොල්ලෝ high school එකේදී මේ වගේ limit හොයන්න ඉගෙන ගන්නනේ. For example this x minus 2. Now if I directly plug in the limit, it's not going to work. No, we can only plug into the, if we know the function is continuous, I can plugging in. Okay, so here I cannot directly plugging in, I simplify it to a continuous function. I can cancel out this and find the limit. No, okay. So with that, you can come up with way to okay, this one okay, this is the idea. So if you limit also has these rules, okay, like we had for the limit of a sequence, we have these rules. Okay, we can multiply and take the limit. These rules we discuss for a sequence also, they are for a limit. Okay, so if you apply the quotient rule here, you get 0 over 0. Reason is this function is not continuous. So we cannot find the at 5. We cannot find the limit at 5 by plugging in. But if you factor this, okay, denominator and the numerator and cancel the minus 5, I can plugging in for this function continuous. Okay, so for this one I can plug in the limit and find it. Here explains the theoretical thing in the note. I'll upload it. Okay. Sometime today or tomorrow. I need to check for the typos. Okay. මේක මම අප්ලෝඩ් කරන්නම් හෙට හරි අනිද්දා හරි මේ typos බලන්න ඕන මේ විදිහට ලිමිට් එක කැන්සල් කරලා හොයන හැටි ඕගොල්ලෝ ඉගෙන ගත්තා මේ A level වලටනේ හරි මෙතන මේ කෙලින්ම දැම්මොත් බිඳුව මෙතන ඒ theoretically විස්තර කරලා තියෙනවා ඇයි එහෙම කරන්න පුළුවන් කියලා okay so I will upload this note with more complicated details more with more details okay මේක වැඩි විස්තර එක්ක මම අප්ලෝඩ් කරන්නම් videos එක note එක I just want to browse today and remind you about the limit and what it means okay then for the exam you should be able to identify limit by looking at a graph okay looking at a graph but I'll upload this whole note and highlight which area you need to concentrate for the exam but go over everything before next class okay so here is explained why you can calculate the limit by calculating okay for now if you know how to calculate limit by cancelling it's enough like this ඒක ඔයගොල්ලෝ ඉස්කෝලේ කරලා තියෙනව නේද හොයන හැටි A level වලට මෙතන හරි thank you okay මෙහෙම cancel කරලා හරි එතකොට එහෙම හොයන්න දන්නවනම් සහ මේ graph එකක් බලලා limit එක දන්නවනම් හරි okay then there is one important thing called the intermediate value theorem here this cos sequence okay finding the limit of sin x over x and cos I put the video for this one now I'm trying to go to the okay this intermediate value theorem okay it's important for so intermediate value theorem function is continuous at all the points then we call it a continuous function okay all the points in the domain okay function එකේ domain එකක් කියලා තියෙනවා codomain එකක් කියලා තියෙනවා ඒකේ ඔක්කොම points තියෙනවා නම් domain එකේ තියෙන ඔක්කොම points වලදී continuous නම් function එක continuous okay so example this function is continuous because it's continuous at all the points. This one is not continuous at this 3, no, only 3 because there is a jump, okay? So all the other points function is continuous. So this function is continuous at 2. This function is continuous at 0, but as a whole function is not continuous. මේ function එක තුනේදී අරගෙන අනිත් ඔක්කොම point වලදී continuous. ඒ වුණාට අපි ඒකට continuous function එකක් කියන්නේ continuous function එකක් වෙන්න නම් ඔක්කොම domains value වල continuous වෙන්න ඕන. හරි? මේකත් continuous නෑ මෙතන jump එකක් තියෙන හින්දා. එතකොට එහෙම ඔක්කොම continuous ඒ වගේ continuous function එකක් ගත්තොත් this mean value theorem is there. Okay? mean value theorem එකෙන් කියන්නේ function එකේ points දෙකක් continuous නම් function එක ඒකේ මොනවා හරි අපි y value දෙකක් ගත්තොත් මේ y value එකේදී function එක define නේ මේ fb value එකේදී define so function I'll make it more okay this function is defined at a okay and fa so for fa function has a value fb function has a value okay So its fa function has a value. Fa function has a value and fb function has a value. So any number in between those two function will have a value, no? So this, sorry. Here. So function have a value at this point, fa and fb. Now any value between these two, that means any value from here, I draw a horizontal line is going to meet function, no? At least one value. Okay, actually one value because it's a function. No, yeah, at least one value. You can get more than value. One value here, he get three, no? Okay. At least you get one value in between. Okay, so if you take two function values, intermediate theorem says in between at every value function will have at least one value. Okay, so here I am looking at the value fa, and if this, let's say t, no, let's say something x L1. Okay, so if L1 is between this fa and fb, then there is some x, so that fx equals L. Okay, so if you take to any function values, in between all the values function will have at least one. So here it has 2 giving that value, here is 1x, no? Here's 3x. එතකොට mean value theorem එකෙන් කියන්නේ අපේ function එකේ අගයන් දෙකක් ගත්තොත් මෙතන මේ fa කියන එකයි fp එකයි ඒ දෙක අතර තියෙන ඕනෙම value එකකට function එකේ output එකක් තියෙනවා කියලා. දැන් මේක ගත්තොත් මම මෙන්න මේකෙන් එනවා output එකනේ. At least එකක් හරි තියෙන්න ඕන. Here if I got it, there are 3 inputs giving the same. මේ m එක ගත්තොත් input 3කින් දෙනවා. මේ output value එකක් දෙන at least එක value එකක් තියෙනවා කියලා තමයි කියන්නේ mean value theorem එකෙන්. function එක continuous නම්. function එක continuous නැතුව jump holes තියෙනවා නම් එහෙම වෙන්නේ නැහැ නේ. උදාහරණයක් ඇටියට අපි මේ function එකට ගියොත් මෙතන jump එකක් තියෙන්නේ නේ. මෙතන jump එකක්. එතකොට මම function value, if I take the function value here, there's a jump. Here I take the function value 1 and let's say 3. Now if I take 1.5, it's between 1 and 3, but oh okay, this function have actually. So continuity, even it break the continuity, this rule might hold or might not. Okay, so here again have, but if I go for that original one of these guy, here. Okay, if I look at this function, so here at 4 is a function output, no? Also 6 is a function output. So if I got this point here, this point, that is between these two, but there is no function value at that point, no? Okay, so this function is not continuous, that's why. Okay, so if function is continuous, whatever the two function values you pick, every value in between will have a input that gives that output. Okay, ඒ කියන්නේ function එක continuous නම් ඕනෙම අගයන් දෙකක් ගත්තොත් ඉතින් function එකේ ඒ දෙකේ තියෙන ඕනෙම number එකකට ඒක දෙන input එකක් තියෙනවා. හැබැයි continuous නැති වුණොත් ඉතින් ඒක නැහැ. Okay, that is the intermediate value theorem. Okay, do you have any question about that one? ඒක ගැන මොනවා හරි ප්‍රශ්නයක් තියෙනවද? chat එකයි නේ. Okay, good. Okay, So that is the intuitive ideas about the limits. Okay. Now I go to okay, so continuity, you need to know how to use those graph and tell the limit, and then algebraically calculating few limits. I put a video for that, if you know, because yeah, I will now we will move on to derivatives. Okay.
The derivative. Defining the derivative. This video is the first video of a series of videos about derivatives. In this video, we will construct a formal definition. Now that we have both a conceptual understanding of a limit and the practical ability to compute limits, we have established the foundation for our study of calculus, the branch of mathematics in which we compute derivatives and integrals. Most mathematicians and historians agree that calculus was developed independently by the Englishman, Isaac Newton, and the German, Gottfried Leibniz. When we credit Newton and Leibniz with developing calculus, we are referring to the fact that Newton and Leibniz were the first to understand the relationship between the derivative and the integral. The derivative extends the concept of the slope of a straight line to other functions. Let's begin our discussion by revisiting the slope. A straight line or line is an endless one-dimensional figure that has no width. It can be thought of as a connected set of infinitely many points. A straight line does not have any curve in it. The figure on the right is of a straight line, but the one on the left is not of a straight line. The one on the left contains curves.
Give me a minute. Okay.
The word slope, gradient, incline, pitch, is used to describe the measurement of the steepness of a straight line. The slope of any line remains constant along the line. The higher the slope, the steeper the line. The blue line has a slope of 2, the green line has a slope of 6, and the purple line has a slope of 20. Observe that the green line has a higher slope than the blue line, and it's steeper than the blue line. The purple line is the steepest and it has the highest slope. Slope m, of the straight line passing through the points P with coordinates x1, y1, and q with coordinates x2, y2, is obtained by dividing the difference of y coordinates by the difference of x coordinates as shown in the formula. Slope can be calculated by using the coordinates of any 2 points on a line. The concept of the slope, the rate of change of straight line, could give important information. The slope of a mountain measures the steepness of the mountain. Also, for instance, the slope of a line could represent change in height over time, velocity, speed, or acceleration. In this instance, according to the graph, the object has traveled 20 meters in 5 seconds, so the speed is 4 meters per second. As you see in this case, the slope gives the speed. Except for rare examples, Most of the time graphs we find in applications are not straight lines, but still, we would like to know the rate of change for those graphs. Unfortunately for curved graphs, the rate of change varies from point to point. The slope formula for straight lines does not work in these situations. Example 2. The position of a car is given by ft equals t squared. Can we find the speed of the car after 1 second of motion? Let's try the slope formula. If t is equal to 1, then f1 is equal to 1. Therefore the point, 1, 1, is on the graph. We need another point. If t is equal to 2, then f2 is equal to 4. Therefore the point, 2, 4, is on the graph. Let's label the point, x1 y1 equals 1, 1, x2 y2 equals 2, 4. Applying the slope formula. The slope m is equal to the difference of y coordinates y2 minus y1, divided by the difference of x coordinates x2 minus x1. Let's plug in the values. Y2 is 4, y1 is 1, x2 is 2, and x1 is 1. By simplifying we get a slope of 3. Observe that if 3 equals 3, then f3 is equal to 9. Therefore, 3, 9, is on the graph. If we pick x1, y1, equals 1, 1, and x2, y2 equals 3, 9, and apply the slope formula, we get a slope of 4. Here we get two candidates for slope at t equals 1, but the car should have only one speed at t equals 1. How do we know the correct one? Actually, neither is correct. Straight lines have a constant slope, but this is not true in general. The slope formula of a straight line does not work for ft equals t squared. We cannot speak of the slope of t squared because it varies from point to point. In the face of nonlinear functions, the slope formula of a straight line fails. Mathematicians introduce a new concept, derivative. The derivative of a function, f at a point p, gives the rate of change of the function, f at p. It extends the concept of the slope beyond the straight lines. Before going into the discussion of the derivative, let's list two crucial concepts. A secant line is a straight line joining 2 points on a function. The figure below shows the secant line connecting point 1, 5.6, and point 3, 2.4. The tangent line, or simply the tangent, to a curve, at a given point is the straight line that just touches the curve at that point. The figure below shows the tangent line through the point 1, 5.6. As you can see, the line just touches the point 1, 5.6. There can be infinite secants drawn through a given point, but there can be only one tangent line through a given point. The problem we faced, when we tried to find the speed at t equals 1, can be explained using secant lines and tangent lines. Observe that applying the slope formula to points 1, 1 and 2, 4, we get the slope of the secant line, joining the points 1, 1 and 2, 4, which gives the average speed of the car in the time interval 1, 2. Applying the slope formula to points 1, 1 and 3, 9, we get the slope of the secant line joining the points 1, 1 and 3, 9, which gives the average speed of the car in the time interval 1, 3. We want to find the exact speed of the vehicle at t equals 1, the value of the speedometer at t equals 1. The slope of the tangent line to the graph at t equals 1 gives the exact speed at 1. We only know one point on the tangent line. The slope formula requires 2 points. Derivative goes around this problem by expressing the slope of the tangent line as a limit of slopes of secant lines. Let's look at the definition of the derivative. For the demonstration, we use a graph of a parabola, but the definition we construct works for any function.
Suppose we have to find the slope of the tangent line to the graph of the function fx at the point with x-coordinate x. Then the y-coordinate of this point is given by fx. We get it by plugging in the x-coordinate x into function f. We have to find the slope of the green tangent line, passing through the point with coordinates x, f, x. Let's label the slope of the tangent line by mt. We only know one point on the tangent line. We can't directly find the slope of the tangent line. Let's move to point h units to right on the x-axis. The point above this on the graph has x-coordinate x plus h and y-coordinate f x plus h. We get the y-coordinate by plugging in x-coordinate x plus h into function f. Consider the red secant line passing through points with coordinates x, fx, and x plus h, f, x plus h. Let's label its slope by mh. The slope m of the line passing through points x1, y1 and x2, y2 is given by the formula 1. Choosing x1, y1 to be x, fx, and x2, y2 to be x plus h, f, x plus h, and applying the slope formula given by 1 to red secant line, we get 2. Where mh is the slope of the secant line. Simplifying 2 by cancelling out x in the denominator, we get 3. As h approaches 0, the red secant line approaches the green tangent line. Therefore, as h approaches 0, the slope of the red secant line approaches the slope of the green tangent line. This could be expressed by the limit statement 4. In 4, replacing mh by 3, we get 5. For a given function f at a point x, if the limit given by 5 is defined, we call it the derivative of f at x. The derivative gives the rate of change of x at point x. Also, the derivative gives the slope of the tangent line to the graph of f at point x.
The slope formula failed for nonlinear functions. The derivative extends the concept of slope to nonlinear functions. The definition of derivative expresses the slope of the tangent line as the limit of slopes of secant lines. This elegant idea is extremely important. Most of the functions we encounter in practical problems are differentiable. In the next videos, we would further explore the definition. We would show how to apply this definition to solve practical problems, including the problem of analyzing the motion of an object whose position is given by a nonlinear function.
Okay. Okay, මං හිතනවා ඔයගොල්ලන්ට මේ වීඩියෝ එක පෙනුණා කියලා. ඒ වීඩියෝ එක පෙනුණා නේද? Okay. Okay, so මේකෙන් කිව්වේ දැන් අපිට straight line එකක මේ හොයන්න දන්නවා නේද? අනුක්‍රමණය එක එක වැඩ කරන්න දන්නවා ඔයගොල්ලෝ. ඊළඟට මේ වගේ curved එකක ගත්තොත් ඒ slope formula එක හරියන්නේ නැහැ. උදාහරණයක් හැටියට මේකේ ඒ slope formula එකට එන්නේ අගයන් දෙකක් එනවා නේ. slope formula එක දාන්න ගියොත් මේ එක එක යට slope එක එකෙන් හොයන්න ගියොත් අගයන් දෙකක් එනවා. ඒකින්ද මේ secant line කරලා හොයන එක slope එක නෙමෙයි එතනදී. ඒක ගන්න නම් මේ tangent line එකේ slope එක හොයන්න වෙනවා. හැබැයි tangent line එකේ දන්නේ ඔයගොල්ලෝ එක point එකයි. හරි. ඒක නිසා මේ tangent line එක secant line වල limit එකක් හැටියට ලියලා slope එක හොයනවා. එතනදී දැන් මෙතන හෙව්වොතින් මේ y coordinate වල වෙනසනේ fx මෙතන fx plus h කියන්නේ මෙතන y coordinate එක මෙතන y coordinate එක fx. එතකොට මේ x plus h වලින් x අඩු කරාම x coordinate වල වෙනස h. එතකොට මේ h එක බිඳුවට යවුවම එන limit එක තමයි මේ tangent line එකේ slope එක. එහෙම නැත්නම් අවකලන සංගුණකය කියන්නේ. හරි. මේකේ හැබැයි මේක two sided limit එකක්. අර limit එකට දෙපැත්තෙන් එන්න පුළුවන්. මම මේ positive side එක විතරයි පෙන්නලා තියෙන්නේ. negative side එකෙන් ගත්තත් h ට ඍණාගයන් දාලා ඕකම වෙනවා. tangent line එකට convert වෙනවා. මෙහෙම straight line ගත්තත් h එක බිඳුවට යද්දී. okay එතකොට මේ two sided limit h0 ට යන මේක තමයි අපි අවකලනය කරනවා කියලා කියන්නේ. හරි? එතකොට මේ definition එකෙන් ගන්න පුළුවන් අවකලන සංගුණිකයේ ඕනෙම point එකක definition එක පාවිච්චි කරලා functions වලට. okay can you see the whiteboard now? දැන් whiteboard එක පේනව නේද? ඔබට whiteboard එක පේනවද?
Yes, sir. Now we can see.
okay so let's say I want to find the derivative of x squared. okay f equals x squared. okay. okay tangent line එකේ slope එක කියලා අපි දැන් කියමු. okay so here I am supposed to find the differentiation different tangent slope of the tangent okay at this point x point. okay so I apply the definition is get x plus h minus fx. okay squared x squared. no here I plugging in x plus h to f this guy. okay this one I can expand. no limit s go to 0 h here I foil it. no x squared plus 2hx plus h squared minus x squared. okay this one I get by expanding this guy. no okay here I can cancel out the x squared. okay when limit 0 I'll get this one now cancelling out. okay. now I can cancel out one limit. no 0 here 1h I can cancel out here. okay so I get what 2x plus h. okay. එතකොට ලිමිට් එක h බිඳුවට යනකොට ලිමිට් එක ප්ලග් කරලා හොයන්න පුළුවන් නේ. ප්ලග් කරලම okay 0 this is 2x. no so the derivative of h equal to 0 you get 2x. okay you learn a formula to do this actually for n. when you have n differentiate you say n xn minus 1. no actually then if I differentiate 2 I bring down the 2. okay not equal but derivative. okay I bring down the 2 and x stays here. okay so this is how you got those formulas if you haven't seen in school. ඔයගොල්ලෝ මේ ඉස්කෝලේ මේක ගත්ත හැටි දැක්ක නැත්නම් මෙහෙම තමයි මේ derivative formulas basic ඒවා ඉන්නේ. හරි එතකොට මේ x plus h උයි fx උයි මේ limit එක හොයන්න ඕන. හරි එතකොට ඔයගොල්ලෝ අර xn එකේ differentiate කරත් ඒක ගන්න මේ formula එකෙන්ම තමයි. එහෙම වුණොත් අපි මේ f කියන්නේ මේක නම් h go to 0 x plus h වල n minus xn over h. okay මේක so this one for the xn, okay, you can simplify that using the binomial theorem and show that this is nxn minus 1, okay. So this derivative, this is how you calculate, okay. I will put two examples how to get this derivative. Once you don't, okay, so that is the derivative. So derivative goes undefined like this. Here I cannot draw a tangent line, no, here and here, okay. Here actually there are infinitely many, here and here, okay, point of discontinuity, okay. So if function is differentiable, it is automatically continuous, okay. So if the limit is defined, these ones are not differentiable, okay. If differentiable, say continuous, okay, that is what I said. If differentiable, let's see, there is continuous, no jump, okay. Converse is not true in general. See here, this function is continuous at this red point, but there are no derivative. Here is the same, okay, this red point, there is no derivative, okay. Then you know about these rules, okay, like that, okay. So for the derivative, these are the notations, okay. You use them in school: dy by dx, d over dx f dash, okay. If you have asked to plugging in a value x equals x naught, you have to plugging in, okay. So I think if you have then f dash is 2x, no. Now if I say dy y equals x squared, I can say dy by dx. Here I'm saying I'm differentiating with respect to x. Okay, I can bring down the 2, no. If I say something like this, x equals 5, that means I have to plug in 5 after differentiating, no. After differentiating, I'm plugging 5, that is 10. Okay, or if I say y equals x cube, okay, y dash or dy by dx, okay, or I can say fx equals x cube, okay. If I say f dash 3, that 2, let's say f dash 2, that means I differentiate and plugging in. If I differentiate, I get 3x to the 2, no. Then when I plugging in here, 2 square, 3 times 4, 12, no. Okay. Okay, that is the these are the symbols for derivative. I think you already know that one too. Okay. Now derivative have two physical meanings. Okay. So one physical meaning is it gives the tangent line. Okay, for a curve, other one rate of change, speed. Sorry, rate of change of that function at that point. Okay. So this one asks you to find the tangent line to the graph of y equals 3x squared plus 1. Okay. So this example, I label it as 1. Okay. Y is equal to 3x squared plus 1. Okay. Find the tangent line, slope of the tangent line at x equals 1. Okay, so this graph I'm drawing here is not the correct graph, okay, because this is just to explain what's going on. Okay, this is not the correct graph of the tangent line, but we don't need the correct graph, no. Okay. Okay. Okay, so here I need to find the equation of this tangent line. Okay, so y equal m, y naught. Okay, this is from high school, you know, if you have a straight line and a point on the line. Okay, if you have a point on the line, let's say x naught and y naught. Okay, this point and the slope m, then you can find the equation of tangent line from this formula. Okay, equation ඔගොල්ලෝ දන්නවා tangent line එකක් තියෙනවා නම් ඒකේ equation එක මේ ඕනෙම සරල රේඛාවක equation එක මේකෙන් හොයාගන්න පුළුවන්. හරි, ඒකට ඕන point එකකුයි slope එකකුයි. දැන් මේ tangent line එකේ අපිට එක point එකක් ලේසියෙන් ගන්න පුළුවන් නේ. So we can get one point easily on this tangent line x equals 1. Okay, so if I plugging in this 1 to the function, I get what? Here I will plug in a side sketch 3 here plus 1 4, no? So when x is equal to 1, y is 4. Now I need the m. So m is the slope of the tangent line. Okay, m is the slope of the tangent line. I can get it by m slope of tangent line. No, I can say f dash. No, maybe if I say dy by dx at x equal 1. No, so first I differentiate this guy. That is 2 comes down 6x plus 1. No, 6x plus 1. I have here x equals 1. So if I plugging in 6 times 1 plus 1, 7. Okay, so 1 7 is, sorry, not 1 7, 7 is the slope. No, so I have 7, the slope of the tangent line 7. Okay, so I can plug into this formula 7. Now my m is, I'll do here, my m is 7 and my x naught y naught is 1 4. No, එක 4. හරි, එතකොට මේ සමීකරණ equation of the tangent line x minus 1 plus 4. You don't have to simplify because it doesn't ask to give you in any form. Okay, just ask to find the formula of the tangent line. So you have to always remember that derivative, one interpretation of derivative physical gives the slope of this tangent line to the graph. Okay, it is also just an extension of the idea of a straight line, slope of a straight line. Okay, then the other idea is rate of change. No, because here if you look at tangent line, this x plus h naught is change of y coordinates. No, and x plus h naught minus s in the denominator have the x. So here we are looking at the rate of change. No, how is y going to change when x change? Okay, so that is rate of change. So rate of change, okay, instantaneous rate of change of that point of fx at x naught. This one gives that. So that means if you like physically, if you st represent the position of object in time t, to get the velocity you have to differentiate it one no ඒක වාහනයක position එක දීලා තියෙනවා නම් function එකකින් එයාගේ වේගය හොයන්න differentiate කරලා හොයන්න පුළුවන් මොකද ඒක change වෙන rate එක acceleration එක හොයන්න නම් මේ rate of change එකත් ආයි differentiate කරන්න ඕන okay උදාහරණයක් ඇටියට මම motion එකේ අර t එක ගත්තා කියමු ඉස්සෙල්ලා ft t squared මේක වාහනයක් නම් මට තප්පර දෙකේදී ස්පීඩ් එක හොයන්න ඕන නම් දැන් මුලින් හොයනවා ft 2t නේ then if I want the speed at 1 t equals 1 here I plugging in okay 1 so speed is 2 whatever the units you use time if I use hours and meters how much meters per hour like that or kilometers okay okay so do you have any questions up to now I think up to now things you knew from school we did some okay I will upload details videos and the note by tomorrow okay now okay am I going too fast or are you able to follow this one දැන් යනවා වේගය වැඩිද ඕගොල්ලොට මේ okay මට chat එකේ වන්න වේගය වැඩි නම් okay so this derivative concept you can use to get the shape of the graph okay okay graph is called strictly increasing okay strictly increasing if x1 is less than x2 fx1 is less than fx2 නේ graph එකක් strictly increasing කියලා කියනවා අපි මේ වගේ එක ගත්තොත් මේ here I have x1 here I have x2 okay then here this is fx1 this is fx2 no okay so if I have this if this fx1 less than fx2 okay imply මේ x1 එක අඩු වෙලාවට මේ fx1 උත් fx2 ට අඩු වෙනවා නම් increasing කියලා කියනවා අපි okay then decreasing is other way around no I have x1 x2 but Okay. Draft එක මේ පැත්තට යනවා. This is x1, this is x2. So now fx2 is less than fx1, no? Okay, that is the definition of increasing and decreasing. මේක වෙන හැම වෙලාවටම මේ ඒ පැත්තටම inequality එක තියෙනවා නම් decreasing, increasing. මේක මාරු වෙනවා නම් decreasing. Oh, I have it also here. See, x1 bigger than x2, fx1 and fx2. Oh, sorry. Give me a minute. Okay, there is a different question. Give me a minute. There is a question. Let me check. Okay. Thank you. Okay. Okay. Monotonically increasing. The way we define monotone, we can have that. So we can have that monotonically increasing. We use that here. We allowed the inequality, no? Here, when we say increase, we allowed the equal sign here. Okay. But when we say strictly, this equal sign is not here. So for example, this one, I can say increasing. Okay. This graph, that is something not decreasing. Something that is not decreasing, we call increasing. But strictly increasing means these flat values we cannot have. Okay, මේ flat values තියෙන්න බෑ increasing කිව්වොත්. මේක increasing. හරි? හැබැයි strictly increasing කිව්වොත් මේ flat values තියෙන්න බෑ. Okay, ඒක පැහැදිලිද දැන්? I think hope it's okay. We are not allowing this flat values when we say strictly increasing. Okay. Is that clear to the person now? Okay, good. So thanks. Okay, so this is the increasing definition. Increasing x1 bigger than x2. Every time this same inequality hold, here is change. No, fx1 is bigger than fx2, like this picture here. We have this, no? x1 bigger than x2. Here we have fy1 is bigger, no? So here is fx1, fx2, and other way around, x1, x2, fx1 this time greater, no, than fx2. Okay, inequality flipped. Okay, now you can use derivative to tell where function is increasing. Okay. Okay, monotone f is a differentiable on the open interval AB and if f dash x is bigger than 0, okay, for every point in AB, then function is strictly increasing on AB. If fx dash equals less than 0, strictly decreasing. Okay, if f dash 0, that means it will remain flat. Okay, because there is no change. Okay, so this is what it's saying. By looking at the derivative, අපිට derivative එක බලලා function එකක් increasing ද නැද්ද කියලා කියන්න පුළුවන්. මොකද rate of change එකනේ ඒක derivative එක නැත්නම් tangent එකේ slope එක. නේ? ඒක positive වෙලාවට function එක increase වෙනවා. negative වෙලාවට function එක decrease වෙනවා. 0 තියෙන වෙලාවට function එක මේ derivative එක continuous වෙලාවට අපිට, so when derivative is continuous, we can identify where the function is increasing and decreasing by looking at this function. Okay, so here the steps to find the effect in increasing and decreasing intervals in a function. First you have to find f dash. මුලින්ම f dash හොයනවා, ඊට පස්සේ f dash බිඳුව වෙනතන් හොයනවා, ඊට පස්සේ mark the points in the number line, pick a test value. Okay, I will show you with this example too. X cubed 12x squared plus 45. Okay, okay, I'll do it exactly here. So okay, okay, so if I differentiate this one f dash, no, I think all you guys know how to differentiate. I bring down the 3, මේ 3 ඉස්සරහට ගේනවා, x 3 minus 1 2, no, that is n derivative of xn n xn minus 1, no, this formula. Okay, 12 and this 2 comes down and multiply 12 24, 1x, no, and plus 45. Okay, now I set f dash to 0 and solve for x, no. If I set f dash to 0, that means this equation is 0, no. (45 equals 0), that is this step, no. I can divide it by 3, I get x, sorry, here squared, no, x squared plus 12x plus 15 equal to 0, not 12, no, I divided by 3, 8, no, sorry. Now I can factor x plus 3 and x plus 5, no. So it's -3 and -5. These are the points where derivative is 0. Okay, so I find the point where derivative is 0. The reason is if derivative going from negative to positive, it has to go through a 0 point because the derivative is continuous on this function. Okay, so this f dash, the derivative is continuous, no? See, this derivative is continuous. Okay, so we can find where it is increasing and decreasing by setting the derivative to 0 and solving for x. Okay, because I am going to find where the derivative is increase and decrease. Okay, මෙතෙන්ට එනකන් ප්‍රශ්නයක් තියෙනවද? මම ඩෙරිවේටිව් එක හොයනවා මුලින්. ඊට පස්සේ ඒක බිඳුව වෙනතන් හොයා ගන්නවා. මොකද මේක increasing ද decreasing ද කියලා බලන්න අහලා තියෙන්නේ. එතකොට ඒක ඩෙරිවේටිව් එක positive නම් increasing, ඩෙරිවේටිව් එක negative නම් decreasing. හරි, එතකොට negative to positive මාරු වෙන්නේ 0 එකක් කරහනේ. ඒක තමයි මේක හෙව්වේ continuously යනකොට I'll explain කරන්න. So derivative is positive means increasing, negative means decreasing. We are looking for paces where is positive and negative, no? So it will change from increasing to decreasing, positive to negative through a point where derivative is 0, no? Okay. So that's why we found point where derivative is 0. Okay, I'll erase this part here. Okay, oh, screen is blurred. Let's put it. Okay, now how is it? Can you see the screen clearly now? Okay, so I'll write again quickly. Okay, මම ඉක්මනට ලියන්නම් මෙතන. මේකයි දීපු function එකනේ. Plus I keep forgetting 12 square plus 12 x squared 45. Okay, three x squared plus 24x plus 15. No, now I set the derivative to 0. I get 3x squared plus 24x plus 15 equals 0. This is a quadratic formula, no? So I solve it, I get -3 and equals -5. Okay. So now I am looking for where this guy positive and negative, no, f dash. Okay. So mark the solutions in number line. Okay. So what I can do, I can draw a number line here. Mark the solutions. -5, -3. Now we are looking at f dash here, where f dash is positive and negative. I know f dash is 0 here, no? Also here f dash is 0. Okay. Now what I do, I pick a test value from that interval. මම ඒ test value එකක් ගන්නවා interval එකෙන්. Okay, ඒක mark the solutions in number line එක උඩ solution ලියලා each sub interval to f dash sec. Okay. So I can get a test value, let's say f3. Here I get -6. Okay. Here I can pick any value. Okay, inside -4. Here I'll pick 0. Okay, so I can plug it. I have to plug this to f dash. Okay, so I'll plug to f dash here, f dash of -6. Okay, this is 36. No, so 3 times 36 is positive, no, and plus 24 times -6 plus 15. Okay, so 72, and so 72 plus 15, 84, no, 87, minus this is bigger, no, 26 times 24 times -6 is 100 something, so I only need the sign. Okay, so this is the test value. I will mark them in red. X negative is the sect value. I am not looking at that. I am looking at the sign of f dash. Okay, f dash at -6. මෙතන ඍණ 6 දී double derivative එකේ dash එකේ sign එක තමයි ඕන නේ. ඒක negative. Okay, then I will put f -2. Okay, if I put that, here I get 12. Here I get -4. No, sorry. Okay, here the test value is -4. No, so 3 times 16, no, minus 24 times -4 plus 15. No, I think I did a mistake in previous one, simplifying. Here 3 times 16, I'll come for that. Okay, so here I get 3 times 16, no, 32, 48 minus this one 4 is 48, 96 plus 15, no, here 16, yeah. Okay, so this is negative, no, so here I get a negative sign. Here I miss didn't multiply correctly. 12, 18 and 9, no, 108 plus 15, that is 123. Then 24 times 6 is what? 6 times 4 is 12, negative 122. Here this is here sign positive, no? Okay, so in this interval I pick one value, sign is positive, here is negative. When I plug here I get it positive. Okay, so derivative, all the values derivative have to stay positive in this interval. All the value, the reason is derivative is here positive. If we want to go, it's continuous also, because polynomial function is continuous. So if we want to go to negative, only point he can go to negative is at this -5, no? So at -5, he can keep going to negative or come up again. That's why I check the value here again. So that is negative means he go to negative. Now, once he go to negative, he is trapped in negative in this interval. Only way to go to 0 is a positive is a through a 0 point. He will come here. Here again, he have to go up or down. No, that's why I check it again here. It's positive means he go up. Okay. මෙතනදී දැන් මේ ඉන්ටර්වල් එකේ එක අගයකදී ඩෙරිවේටිව් එක ඍණ වුණාම එයාට ධන වෙන්න පුළුවන් ඩෙරිවේටිව් එක බිඳුව වෙන පොයින්ට් එකක් කරහා විතරයි නේ මේක කන්ටිනියස් නේ මේ පොලිනෝමියල් හින්දා එතකොට මෙයා මේ ධන එකේ ට්‍රැප් වෙලා ඉන්නවා මෙතෙන්ට ආවට පස්සේ එයාට ඕන නම් ආයේ උඩට යන්නත් පුළුවන් ධන පැත්තටම හැල්ල යන්න පුළුවන් නැත්නම් ඍණ පැත්තට යන්න පුළුවන් ඒක තමයි මම මෙතන එකක් වැලියු එකක් පික් කරේ ඕකේ ඕනෙම වැලියු එකක් මේ ඉන්ටර්වල් එකෙන් කමන්නේ නැහැ ඒක ඍණනේ එයා එතකොට ඍණ 4ට ගිහිල්ලා ආයි මෙතෙන්ට ආවම ආයි උඩට යන්න පුළුවන්. එතකොට මේකේ හොයන්න තිබ්බේ increasing decreasing නේ. එතකොට මට කියන්න පුළුවන් increasing interval මේ ධන ඒවා. Okay. -6 to -5. All this interval is no sorry negative infinity. No, they're not this test value. -infinity to -5 increasing. Also again increasing on -3 to positive infinity. Okay, all of this interval is increasing and all of this interval is increasing. Then it is decreasing on -5 to -3. Okay, so do you have any question here? So this is the final answer, no? මේක පැහැදිලිද ඔයගොල්ලොට? මොනවා හරි ප්‍රශ්න තියෙනවද මෙතන මේ තියෙන pick a positive test value? Okay, මේකේ මොනවා හරි Okay, good. Thank you. Okay. මේකේ මොනවා හරි පැහැදිලි නැත්නම් තියෙනවද මම වේගෙ වැඩියෙන් යනවා නම් කියන්න. Okay, if I am going too fast, okay, we'll take a 5-minute break and then I'll start again. Okay, we will do until 12 today. Okay, I'll take 5 minutes break.
Excuse me, sir, we can't hear you.
Okay, sorry. So now you have some idea how the graph is increasing and how the graph is decreasing, no? Okay, sorry. So you know if the graph positive straight line, positive slope of a straight line this like this, no? Negative slope of a straight line is like this. Now derivative is the same extended concept. So graph will be increasing with positive slope and decreasing with negative slope නේ positive slope එකක් නම් graph එක increasing මෙහෙම x වැඩි වෙනකොට මේ x වැඩි වෙන පැත්තට එහෙම y වැඩි වෙනවා ඊට පස්සේ x අඩු වෙනකොට y අඩු වෙනවා decreasing නම් no if decreasing as x increases y go down so you can get some idea about how the shape of how the derivative effect in the graph no here 50 here dash negative no so because it's the extension of the thing okay you can hear me now no
Yes, sir.
okay thank you okay so then with this I have this absolute minimum and absolute maximum okay here this absolute max is the highest point of the graph is greater than or equal to all the other points okay this is lowest point okay so for example if I okay this is absolute max no highest point on the y value okay I'm thinking this y is increasing like this yeah, this is absolute max no this point here and this is absolute mean because lowest one even I have a graph like this if I have something like this then I have more than absolute max no all of this is absolute max no and this point is absolute mean okay මේ දෙක absolute maximums හරි මේ ඔක්කොම ටික absolute max න මේක absolute mean මේක absolute mean උසම තනයි graph එකේ උසම points උයි lowest points උයි okay then you have relative max and relative mean okay where if there's an interval containing c on the which fc is maximum කියන්නේ එයා වටේ interval එකකදී maximum නම් එයා relative max එකක් එයා වටේ interval එකක් හොයාගන්න පුළුවන් if we can find the interval around a certain point he is the maximum he is a local maximum if we can find the interval around a certain point he is minimum then he is a minimum so if we go to the here if I think this interval around his okay I have this point and then I can find the interval even how small it doesn't matter okay so in this interval is max no then this is a relative max okay Absolute max is also relative max for sure, no, because you can think as interval the whole domain here, because in here whole domain he is bigger than this, he is a relative max also. Okay, and this guy also, now relative mean is a point where you can find interval around him is minimum. So here interval around him, this is relative mean. Also this guy is a relative mean, no, because I can think of එතකොට relative max relative mean කියන්නේ ඒගොල්ලෝගේ ඒ ඉන්න point එක වටේ හොයාගන්න පුළුවන් interval එකක් එයා minimum වෙන. දැන් මෙයා ගත්තොත් මට එයා වටේ මේ interval එක එයා minimum නේ. මේකේ max relative max මොකද මේ interval එක වටේ එයා maximum. කොච්චර පොඩි වුණත් කවන්නේ නැහැ මේ interval එක. හරි? ඊළඟට මම මෙහෙම එකක් ගත්තොත් එයත් okay, definitely a relative max and absolute max and absolute means are also relative means and relative max, right? Here even I have 0.1. This is also a relative max. Okay, in this case is also absolute max. This is a relative mean, no? Now we can find relative max and relative means using derivative, because critical point. Okay, what is a critical point? Is a point where derivative becomes 0. Okay, critical number or a critical number is where, okay, and the point related to that is the graph is called the critical point. Okay, so f dash equals to 0 or f dash is undefined and the graph is defined. Okay, f is defined at c, f dash is 0 or f dash is undefined, then critical number of f. Okay, why? So for example, if I look at here, it's a sharp point, no, then the function is defined at this point but the derivative no, not. But these ones derivative becomes 0, no, when it changes smoothly derivative is positive, then it becomes 0 and then it goes to negative. Here derivative stay positive, smoothly change to 0 and then to negative. So this one also critical points where derivative becomes 0 and then these sharp turns, so these points also critical endpoints. Okay, those points function is defined but derivative is undefined, no? Okay, so the critical points of a function are graph or a function are the points where derivative becomes 0 or derivative is going undefined. Okay, in the domain. Okay, derivative එකට undefined හරි function එක define නම් එහෙම point. Okay, okay, so to critical points, to find the first step is set derivative to 0 and solve. We already saw how to do that one. Okay, and other point where f is defined but f dash is not defined, those will also give critical numbers. Okay, I'll come for this step 3. Now if I ask to find the critical numbers to this, what I have to do? I have to do is just find the solution of the derivative 0. Okay, so the if I go for this first one, critical points are going to be the okay, if I have here critical points going to be the points where derivative becomes 0. No, we already did this problem. So x equals what? -3 and -5. No, we before did this one. So that are the critical points. Okay, so here I just set to 0 and solve. Other way to find critical points is අනිත් විදිහ මේ f dash එක undefined. Okay, උදාහරණයක් හැටියට function එක define. Okay, උදාහරණයක් හැටියට if I take this one, okay, fx equals x to the half, or let's say 1/3. Okay, then f dash x equals, I bring down the 3, no, 1 to the 3, 3, I do 1/3 minus 1, no, so that is 1/3 x -2/3, no? This one I can write 1/3 x 2/3, no? Now when x is 0, if I try to find f dash 0, here I get a denominator 0, no? So this is undefined. Okay, but f0 is defined, no? Okay, therefore x equals 0 is a critical point. Okay, function have to be defined. Function එක define වෙලා derivative එක undefined වුණොත් ඒ critical point එකක් වෙනවා. හරි? Okay. If I take this one, 1/, let's say, x squared. Okay. This is -2, no, x to the -2. Okay, so I'll bring down the -2 and x cubed, no? This is the derivative, no? Here at x equals 0, f dash 0 undefined, no? But also function is undefined. So x equals 0 is not a critical point. Okay, මෙතන x equals 0 කියන එක critical point එකක් වෙන්නේ function එකත් undefined වෙලා. හොඳයි. හරි, එතකොට critical points identify කරන්න. Setting the denominator to 0. Okay, of the derivative you can identify, but you have to check that whether the function is defined at that point or not. Yeah, so there are two ways you get critical points: setting derivatives to 0 and identifying points where derivative is undefined. Sometimes you might have to use definition to see whether the derivative is undefined. Okay, so this one, okay, now critical point theorem. Relative maximum or a minimum of a continuous function occur at its critical points. Okay. So local max and local means. Okay. So if we go back to that one, here at a local max or a min, derivative either function smoothly change. No, then derivative becomes 0, critical point. Okay, this is a critical point. Okay, critical point here. This is also a critical point, no, because change. Okay, this is also a relative max. I didn't write relative mean because he is less than all the point around this interval, no. So these points are critical points because derivative is 0. Okay, then these points are also critical points. Derivative is undefined. Here, no? Critical point. Here, critical point. This sharp edges derivative goes undefined. Okay. Here, this interval is the minimum. No, so this is also a relative mean. This is also a relative mean. Okay, because he is smaller than all the values around him. Okay, so all of those are critical points. So before drawing the graph, actually I have to look at the මේක ඔක්කොම මේවා critical points නේ. මේවත් critical මේ relative mean එකක් මොකද එයා වටේ points වලට වඩා අඩුයි යානේ. interval එකක් හොයාගන්න පුළුවන්. මෙහෙම interval එකක් හොයන හැම වෙලේම relative mean උයි max උයි. Okay, so this relative mean or a max, your derivative becomes 0 or goes undefined. Okay, මේ relative min max වල derivative එක බිඳුව වෙනවා නැත්නම් undefined වෙනවා. ඒක තමයි ඒවට අපි critical point කියන්නේ. Okay, so relative min or a max occur at a critical point. So you can look at the equation and the derivative to identify these critical points, because when plotting it's important to turn at those points. Okay, එතකොට මේ critical points පාවිච්චි කරලා මේ හොයාගන්න පුළුවන් relative min and relative max. Okay, then if it's a relative max, graph can look this one, no? If derivative becomes 0 and becomes a relative max, graph look at like this. So here f dash positive, no, it's keep increasing, then comes 0, no, here it comes 0. As it turns it becomes 0, and this side it goes negative. Okay, so here it's 0. Okay, so if it goes like that, that's a relative max or a mean. Okay, then other way, here now here is positive, negative, sorry, positive, 0, negative, no, then is some relative max. Here it's negative derivative, 0, positive, අඩු වෙලා බිඳුව වෙලා වැඩි වෙනවා නේ, negative, then is a relative mean. Okay, so here we are asked to identify relative mean and max. Okay, we can use that previous example. So to find relative mean and max, what you need to do like that before, find all the Okay, critical points and man or a mix, okay, or neither. Okay, now other one is like this. Okay, critical points can come like this also. Sometimes critical point might not give you, so function can go like this. Okay. So plus, negative, relative, max. Okay, 0, negative, relative mean. Then I can get this. Okay, here plus derivative 0, again derivative part. Then we call it inflection point. Okay, inflection point. Here again, also I can have that, this, no? Negative, 0, again negative. Then it's not a max or a min. Okay. So this one asks us to identify again relative max and min. Here, okay, so it's the same thing. First I set the derivative to 0 and identify here. Okay. Here we can see here derivative becomes 0 at this point. Okay. So I know this is a critical point. Critical point, and this is also a critical point, no? Negative 3. Okay. So this is the graph of derivative, not the original graph, no? This red one. Okay. So x equals -5. Okay. I'll write it in a clear page again. So my fx is x cubed plus 12x plus 45, no? So I did f dash x and got 3x squared plus 24x plus 45. Setting this to 0, I got -3 and -5, no? So this interval -5, -3, මෙතන -3, -5 තියෙන එක මේ -5 -3 තියෙනවානේ. එතකොට මෙතන ඩෙරිවේටිව් එකේ සයින්ස් ආවේ මෙතන ප්ලස්, මෙතෙන්දි 0, මෙතෙන්දි negative. Okay. So can you tell whether this -5 is it a max or a mean? Relative. Okay. Is this a relative max or a mean -5? Can you tell?
Max.
Good. Okay. Let's see. Yeah. Let's see. Plus, yeah, good. Plus 0 down, no? Max. Because plus means this side, 0, this down. Good. Okay. And this one down, and then here it becomes 0 and goes up. So this is a up. Okay. Okay, concavity of a function. Okay, concavity of a function is, okay, one of them is concave up. Here, let's see the definition. Okay, okay, here, sorry. Concave up in the interval all the tangents to curve I are below the graph. Okay, මේ tangent එකට අදාළ points ඔක්කොම below නම් තියෙන්නේ මේ ඔක්කොම below නම් තියෙන්නේ concave up. Okay, මේ shape එක. මේ shape එක නම් තියෙන්නේ concave down. Okay, so concave up means rate of change of the graph changing increases. See, this is increasing, it become more increasing as we go along this in the positive direction. Okay, and that means second derivative have to be positive. Okay, because it's the rate dependent to the rate of first derivative. If first derivative is increasing, okay, that means second derivative is positive and the second derivative is negative. Okay, if concave down, second derivative is negative because then it's slowing down. It's increasing but it's slowing down the increase. Increasing ගතිය වැඩි වෙනවා නම් concave up, increasing ගතිය අඩු වෙනවා නම් concave down. ඒ වගේම decrease ගතිය okay, decrease ගතිය අඩු වෙනවා නම් concave up, decrease ගතිය වැඩි වෙනවා නම් concave down. Decreasing එකේදී ඒක අනිත් පැත්ත වෙනවා. මොකද මේ f dash positive negative නිසා. හරි? So you can get it from the f dash. Okay, interval එකක positive නම් concave up, negative නම් concave down. Inflection points is a point where the function continuous at the point and concavity of the graph changes at that point. Okay, එතකොට ඒක second derivative එක බිඳුව කරලා හොයන්න පුළුවන්. Find the where. Okay, so to identify concave up and concave down, you have to do the same thing with the second derivative. No, what we did for the first derivative, you have to do with the second derivative. Okay, so if we go to this example again, this one x cubed plus 5x squared plus 6. No, okay, so fx equals x cubed plus 5x squared plus 6. Okay, so first I find f dash for the concavity because I differentiate it once, no? 10x, and then I do f double dash, no? 6x plus 10. Sorry, 6x, just 6x, no? Now I need to find where he is positive and negative, no? So that means, again, he is taken the positive and negative from the 0 point. So I will check f dash x equal to 0. That is 6x plus 10 equals to 0. Okay, so x equals what? Negative 10 over 6. Okay, negative 5 over 3. Okay, so I have negative 5 over 3 here. Okay, now I have only 1 point, so I have 2 intervals either side. Okay, so I have to pick a test value. Here it's always easy to pick 0, no? This side, no, other side. 0 is there, so I pick 0. This side I'll pick negative 4. Okay, so if I plugging in f0, this is 6 times 0 plus 10. So this interval is positive, no? And if I plug negative 4, 6 times negative 4 plus 10, no? Negative. So this interval is concave down. Okay, let me, yeah, concave up in the positive. Okay, concave up in negative infinity to negative all of this interval, no? Negative infinity to negative 5 over 3. Okay, concave down negative 5 over 3 to infinity. Okay, did I wrote it other way? Yeah, no, I switched actually. This is concave down. This is concave up, no, sorry. Okay, in this interval is concave up. Okay, and this interval concave down. Okay, let me. Okay, those points are inflection points. So that 5 over 3 is a inflection point. Okay, then there is the second derivative test for the critical point. Okay, so the second derivative test says if derivative is positive, is a f dash equals 0, and second derivative is positive, then it's a relative maximum. If the second derivative is negative, it's a relative minimum. Okay, if second derivative is 0, test fails. Maximum or a minimum or neither, you have to check it with the first derivative check. Okay, so if you look at this example, 3x to 5 plus it's not erasing. 3x5 plus 5x3. Negative, no? Okay. Okay, I'm right. Five x3. Okay, so f dash x negative 15 x to the 4 x squared, no? So here first I have to find the where derivative 0. I can pull out x squared times 15. If I get this here, I get negative 50, negative 15 x, no, sorry, negative x squared plus 1, no? So if I solve here, x equals 0, and I get here from this plus or minus 1, no? Equals plus or minus 1. So I have x equals 0, x equals 1, and x equals negative 1. Now I have to check whether these are relative max and min. Okay, one way to do that, do the first derivative check. I showed like draw the chart. Okay, otherwise what you can do, second derivative test. For that I need a second derivative. Okay, so I differentiate this guy, no? Negative 60 x cube plus 30 x. Now I check for each of them. Okay, first I check for negative 1. So negative 60 times negative 1 to the cube plus 30 times negative 1. Okay, so this is comes plus and 30, 30. So the second derivative is positive. So according to our test, if second derivative is positive, is a relative minimum, no? Okay, so I can say x equals negative 1 is a relative minimum. I'll explain why in a minute. Okay, then I do f to the 1. Here I have negative 60 plus 1 plus 30, no? So it's negative 30 relative max. Okay, so x equals 1 is a relative max. Okay, මේක බිඳුව කරලා හොයන්නනේ තියෙන්නේ නේද? බිඳුව කරලා හෙව්වම මේ ඒක second derivative එක positive නම් relative minimum එකක්. Second derivative එක negative නම් relative maximum එකක්. ඇයි එහෙම වෙන්නේ? මොකද මේක increasing නම් එන්න second derivative එක අඩු වෙනවානේ. මේ පැත්තට යද්දි ඍණ වෙනවා කියන්නේ අඩු වෙනවා. ඒ කියන්නේ rate එක අඩු වෙනවානේ function එකේ second derivative එකේ. මොකද මේක decreasing කියන්නේ ඍණ වැඩි වෙනවා කියන්නේත් අඩු වෙනවා. මෙහෙම වෙනවා නම් මේ first derivative එක එන්න වැඩි වෙනවානේ. First derivative එක වැඩි වෙනවා කියන්නේ positive. So here if you have a max throughout that one, second first derivative is decreasing. Okay, so that's why it's second derivative gives the rate of change of the first, no? එතකොට x එක බිඳුව දැම්මොත් මේකේ 0 එනවා. ඒක unconcurrent 0. Okay, so then for that one you have to apply the first derivative test. Okay, so for that, to finish the question, I have to find apply first derivative test for this 0. Okay, so you have to do like this 0 and pick little bit of a closer line because here also I have one. So now test value pick from this interval, okay, 0.5 or something. I will not do that one. I put it in the video. Okay, and then for this second one, I have to use the first derivative test. Okay. So do you have any other questions about this? Do you have any question about what we did today? I will tell about the exam minute. Then series ones, do you have any questions? Okay. Okay, I will put this notes by tomorrow, and the I have to check for the typos just by tomorrow, and also I'll upload videos by tomorrow. Okay, Lopita rule I'll give a refreshing. So I will upload this note with videos and today's lectures video. Okay, I think this stuff was clear. So there is one thing, mean value theorem. I will put a video for that. Okay, then I will tell you what areas you have to focus, because this one we did quickly. Okay, so for exam right now I am thinking uh, 2 questions from sequences. This might change a little bit. Okay, I will upload with the review on Monday. 2 question sequence, one between 1 to 2 from series. Okay, then 1 question from continuity. Okay, 1 to 2 from the derivatives. Okay, so I might give a question, let you choose also, maybe 6. So here I have 5, 6, 8. I might ask to choose 6 questions, or if I might get it down to total 6, maybe I give only 1 from series and 1 from derivatives. Okay, I'll exactly let you know when I made the exam and tried it, number of problem from each section and the structure. Okay, so that is that. Do if you don't have anything in series, I will upload some practice problem as review. You can also submit those as homework. Okay, do you have any question? මොනා හරි ප්‍රශ්න තියෙනවද මේක හරි? ඔයගොල්ලෝ ප්‍රශ්න නැත්තම් log out වෙන්න පුළුවන්. ඔයගොල්ලෝ දාන්න මේක තේරුණාද නැද්ද කියලා. Okay, so you can log out. If you don't have questions, let me know whether you followed today or not. Okay, or somewhat, because then that will help me when I'm making the videos. Okay, to see how much I should explain. Okay, so you can log out, let me know whether you followed the lesson today or not. Okay, because when I upload the videos I will know how much I should explain. ඔයගොල්ලෝට දැන් log out වෙන්න පුළුවන්. log out වෙද්දි තේරුණාද නැද්ද කියලා ටිකක් දාන්න. මොකද මට එතකොට දැනගන්න පුළුවන් මේකේ videos upload කරද්දී. Okay, okay, ප්‍රශ්න නැත්තම් ඔයගොල්ලෝට log out වෙන්න පුළුවන්. Okay, good, thank you. Okay, let me know because I'll be uploading the videos. You're welcome. Okay, තේරුණාද නැද්ද කියලා කියන්න. මොකද මේ okay, good. Welcome. Okay, මම මේක විනාඩි 5කින් විතර log out කරන්න. ඔයගොල්ලෝ දාන්න. Oh yeah, Okay, yeah, I'll upload the answers. After you submit, I will upload the answers for these two, and for other one, I will upload, okay? Okay, good, okay. Okay, our last lecture, I'll upload videos for last one. Welcome, okay. Yeah, okay, yeah, I will upload also this all the PDF video, all the PDF notes for the lectures, all the sections by tomorrow, at least by Monday morning. I need to check for typos, okay? Also series, I will upload a book like note because I upload the PowerPoint slide. It's hard to print that. Okay, so I will upload in this format. Okay, welcome. Okay. Okay, I log out at 12. Okay. Okay, I'll drop out, log out now. I think people understood it. I'll also put some videos for this. Okay. Okay, I'll upload the videos for this and PDF. Okay, I'll stop now. Okay.